In the examination of structure of organisms, we frequently find organs that either have no function or have a modified function completely out of character with the structure. For example, wings are very complex structures specifically adapted for flying. So why do ostriches have wings? Ostrich wings are certainly not useless to the ostrich, but they are certainly useless as wings. The vestigial blind eyes of the mole and cave-dwelling fish and salamanders are easily explained only by reference to previous ancestors who had need of eyes. Snakes are clearly the descendants of four-legged reptiles. Most pythons still carry vestigial pelvises hidden beneath their skin. These useless pelvises are not even attached to the vertebrae, but simply float in the abdominal cavity. Many legless lizards carry rudimentary vestigial legs underneath their skin, undetectable from the outside. Dandelions reproduce without fertilization, yet they retain flowers and produce pollen, useless to the dandelion, but not to its ancestors. Many flightless beetles still carry their fully formed wings of their ancestors, but carry them underneath fused wing covers. Human herbivore ancestors are responsible for our useless wisdom teeth and our vermiform appendix. And our tailbone is a developmental remnant tying us to our ancestors who had external tails. There are no vestigial structures that were not previously functional in an ancestor. All vestigial organs make sense only in the framework of evolution. And of course, we do not find vestigial organs that argue against evolution. No nipples in amphibians, or vestigial feathers on mammals. No primates carry vestigial horns, or degenerate wings. We do not find arthropods with leftover backbones. No snakes have wing parts, and no humans have gizzards. A test closely related to vestigial sections addresses similarities in structure in spite of differences in the functions of that structure. If species evolve from another species, the new species must often adapt and modify existing body parts to do different tasks. If we examine the bone structure in primate hands, and bat wings, and bird wings, and pterosaur wings, and whale flippers, and penguin flippers, and horse legs, and mole forelimbs, and frog legs, we will find they all have the same bones in the same relative positions. The standard tree diagram easily demonstrates why these different species have the same structure. That is, they have common ancestors who possess these structures. The fossil records again confirms this conclusion, as it readily provides a chronological progression of intermediate forms.